Hello everyone, in this video lesson, we will just have a continuation of our discussion about the Coulomb's law. So before we proceed, let's have a review first about the Coulomb's law equation. So in our previous meetings, we have tried solving problems involving two charged objects, and according to the Coulomb's law, it states that the electrical force between two charged objects is directly proportional to the product of the quantity of charge on the objects, and it is inversely proportional to the square of the separation distance between the two. So in other words, when we use the Coulomb's law equation, we try to look for the magnitude of the electrostatic force between two charged objects, and when we use this equation, we only substitute the charge of the charge magnitudes for Q1 and Q2. So we do not use the algebraic signs because we are only getting the magnitude of the force. So in this lesson, we will be talking about the force on a point charge due to two or more other point charges. So, ano ang mangyayari dito sa lesson natin? We will be dealing with planes with three charges specifically. So, frequently, hindi lang dalawang charges ang present sa isang object or sa isang plane. And here in our examples, preceding examples, we will be dealing with three charges. So, what do we do about this? We can actually find the net electric force on one of the charges. So, say for example, in this illustration that we have, we can get, so we have here a plane and it has Q1, charge 2, and charge 3. So, all of these charges experiences different forces from one another. So we can get the electric force, say for example, sa Q1. So anong resultant force ba ang na-experience niya because of Q2 and Q3? So we can find it out using the Coulomb's law. The same goes with Q2. Anong force ang na-experience niya because of the presence of charge 1 and charge 3? And the same goes also, of course, to Q3. What is the force that this charge is experiencing because of the presence of Q1 and charge 2? So, ayan. So, we can actually apply Coulomb's law when there are more than two charges present in a plane. Now, how do we get it? We have to find the resultant force. So, dito sa illustration natin, we are looking for the force exerted on Q1. So, we need to find the resultant force of this Q1. Ano ba ang na-experience na force ng charge 1? And we can do that through vector addition. So, here, please take note of this idea because we are going to use this on the succeeding pages or slides. So, the resultant force on a charge, for example, the charge 1, is the vector sum of the individual forces on that charge. So, simplified, ang makukuha natin ang resultant force ditong charge 1 by adding the individual forces that these two charges are exerting on Q1. Now, once you get the individual electric forces, the magnitude of the individual electric forces, we are now going to add those charges, or sorry, those vectors or those forces together. Now, before we proceed to those examples, let's talk about first vector addition. So when we say vector, again, it is a quantity that has both magnitude and direction, and it is represented using an arrow with a tail and of course a head. And the length of the vector represents its magnitude. So kung mahaba yung arrow that you are going to draw, that means that the magnitude of that that vector that you are representing is large. Kung maikli naman, that means the vector that you are representing, say for example, the force is just small. So maikli lang yung arrow that you are drawing. Okay? So these vectors, they can be added together to find out the resultant of both of the vectors. So say for example, these vertical and horizontal vectors. So the directions and the magnitudes are combined when adding vectors. So kapag horizontal and vertical lang ang direction ng mga vectors natin, napakadali lang. You just need to add them. How about the direction? So the direction is represented by the sign. So if, say for example, here in this first example, so 3 lang ang magnitude niya. So the length of the arrow is short plus 7. So it is much longer. So you just need to add them. So 3 plus 7 is 10. So that is how you add these vectors. So pareho sila positive because they are both, the direction of both vectors are to the right. Now, how about if the direction is to the left? Of course, you need to represent it with a negative sign. So, positive 10 minus 3. So, when you add these two vectors, you will get 7. How about vertical? So, if it is upwards, the value is positive. So, positive 4 plus positive 4, you have an 8. Okay, so the magnitude is much bigger. So the length of your vector is longer. How about kapag negative? Negative ang vertical if it is downwards or going to the south. So that is how you add vertical and horizontal vectors. Now, not all vectors are drawn in a horizontal or vertical manner. There are also vectors that are drawn in an angle. So they are angled vectors. So before we add angled vectors, we need to know first that angled vectors have two components. It has the horizontal and vertical components, or what we call in short the x and y components. So say for example here in the illustration, we have a northwest vector, and this vector has its horizontal and vertical component. So the horizontal component niya is going to the left, and the y component is upward or northward. So when you combine these two components, it yields or it leads to this angled vector, which is a northwest vector. The same goes with this one. This is an upward rightward vector. So it has an upward y component and a rightward x component. Ayan. So these single two-dimensional vectors, they can also be represented using these two components. And these are important when we add angled vectors. So say for example here, this is a velocity. This is a representation of a velocity. So it is this single velocity, the magnitude is 50 meters per second. And the angle or the direction is 60 degrees. Upward, rightward direction. No? So the components of this is the x component of this vector and the y component of this vector or velocity. So those are the components of angled vectors. Sa ano naman, kapag 3-dimensional ang vector natin, there are 3 components. We have the x component, y component, and the z component. Now, the components of the vector, say for example, a force, it can be determined using trigonometric functions. So here, this is an illustration of a dog which exerts a force on the chain. So the force is 60 newtons and the direction is northeast, upright rightward direction, and it has an angle of 40 degrees. So for us to identify the components x and y, we need to use trigonometric functions. So to get the y component, we can use the sine theta. So sine theta is equal to the opposite over the hypotenuse. So if you are going to analyze the illustration, the opposite of this angle is the vertical or the y component. So you can write it here. Sine 40 is equal to the y component all over the hypotenuse, which is the force, 60 newtons. So rewriting the formula, you can get now the value for the y component. Ayan, so it is 38.6 Newton. The same goes with the x component. You can use the cosine theta, which is equal to the adjacent over the hypotenuse. So adjacent to this angle of 40 degrees is the horizontal. So cosine 40 is equal to the horizontal all over the force, the hypotenuse, which is 60 newtons. So rewriting the formula, we have this formula for the x component of this force. So we have 45.9 Newton. So these are the x and y components of the single angled vector. Now how do we add angled vectors? So say for example, we have these two vectors, and this represents forces. We have force 1, force 2. So to add these two angled vectors to produce the resultant vector, we need to analyze this individually. So as I have mentioned a while ago, two vectors interacting with one another yields or results to another vector. Okay, so meron dyan na resultant vector na mapuproduce because of these two vectors. So again, to get that resultant vector or to add these vectors, we need to analyze them individually. So we have to get first the components of each individual vectors. So paghiwalayin natin sila para mas masimplify. So this is the first force, F1, and this is F2. Ayan. So ito lang siya, and this one. So you need to get first the individual, the components of each of these individual vectors. So for F1, this is our x component, and this is the y component of F1. For F2, this is the x component and the y component is here. Yan. After getting the components of each of these individual vectors, you are now going to add the x and y components. So you add the x components of F1 and F2. So you get f of x. So the resultant, the x component of the resultant force is just the sum of these x components, And the y component of the resultant vector is also the sum of the y components of these two vectors. So that is how you add that. And then, since you have now the x and y component, you can now use the Pythagorean theorem to find the magnitude of the resultant vector. Now, how about the direction? For the direction, you are also going to use the trigonometric function. So, it's either sine, cosine, or tangent. Any of those three can be used to find the direction or the angle of the resultant force. So, later on, we are going to have an example for these angled vectors. Okay, so let's begin with a simple example on three charges. So this time, in this example, we can see here in this illustration that there are 3-point charges that is lying along the x-axis. So here, we have to determine the magnitude and direction of the net electrostatic force on Q1. So our focus here should be on Q1, which is equal to positive 3 microcoulomb. So anong gagawin? We are going to determine ano ba ang net electrostatic force na na-experience nitong Q1 because of the presence of these two charges around it. So, first step that we are going to do is to draw the free body diagram. And actually, meron na tayo. So, this one is the free body diagram for Q1 or for the forces acting on Q1. So, first, you are going to consider or analyze the signs of the different charges around Q1. And of course, the sign of the Q1. So, ang Q1 positive. So, consider muna natin ano yung charge ng charge 2. I mean, the sign. So, the sign of Q2 is negative. So, given the interaction between the two, we can say that Q1 is attracted on Q2 because they have opposite signs. So, the direction is going to the left. Okay? So, ayan. So, that is the force that is acting on Q1 because of the presence of this negative charge. Now, how about Q3? So, Q3 is also negative. As you can see here, it is negative 7 microcoulomb. So, we can say that Q1 will also be attracted to Q3. So, there is also a force acting on Q1 because of Q3. And it is represented by this arrow, F13, or the force on Q1 due to Q3. So, as you can see, the magnitudes of the two are different. It is much longer sa Q3. That is because Q3 has a larger charge. So, we can say na mas malaki yung force na binibigay nitong Q3 sa Q1. And later on, we are going to find it out when we try to solve it or we try to calculate now the magnitude of the individual forces. So, that is the next part na nagagawin natin. So, you have to calculate for the magnitude of the individual forces acting on Q1. So, as I have mentioned on the previous slides, it is better if you treat them individually. So, we have to find first the force on charge 1 by charge 2. Ayan. And you can actually make another body diagram to make it simple. So, if we are going to draw it, ayan. So, the charge or the force acting on Q1 because of this negative charge 2 is like this. It's represented by this vector. So, let's find out what is the force using the Coulomb's law. So, you can just write the formula, represent it by 1, 2. So, that means the charges that you are using are Q1 and Q2, and the distance between Q1 and Q2. So, taking a look at the illustration, the distance between Q1 and Q2 is 0.20 meters. So, substitute that here. Okay? And then, apply mathematical operations. So, I multiplied first the two charges here. So, you will get 1.2 times 10, negative 11 Coulomb squared. You square the separation distance. 0.20 squared is 0.04 meters squared. And then you divide the two values here. You will get 3 times 10, negative 10 Coulomb square per meter squared. And then multiply it with the proportionality constant. And you will get 2.7 Newton. So that means the value of this force acted on Q1 by Q2 is 2.7 Newton. So yan yung na-experience na force ng Q1 because of this negative charge 2. Now, how about the force on Q1 by Q3? Ayan. So, again, you draw another separate body diagram, free body diagram. Ayan. So, Q3 naman ang i-consider natin. So, it has a much longer magnitude. So, let's find what is the force on Q1 by Q3. So, Coulomb's law again. So, this time, F13 na tayo. And the charges are Q1 and Q3. The same goes with the distance. The distance that we are going to use is the distance between Q1 and 3. So, taking a look at the illustration, it is 0.15 meters. So, you substitute all of those values. So, again, mathematical operation, multiply the two charges that we have. So, you will get 2.1 times 10 raised to negative 11 Coulomb squared. Use the square of the separation distance, 0.15 meters, is 0.0225 meters squared. And then divide it to, you will get 9.33 times 10 raised to negative 10 Coulomb squared per meter squared. And lastly, multiply it with a K or proportionality constant, you will get 8.4 Newton. And by the way, this should be F13, F13. Ayan. So, as you can see here, the F13 is really much larger. The force acted by the charge 3 is much larger compared to the charge 2. So, tama ang illustration na meron tayo. So, F13 is represented by a much longer vector. Okay? Because it has a greater force on Q1. So, we are now done with the second step. Now, for the next steps, we already have the magnitudes, right? For step 2 of the individual forces, F12 and F13. Now, we can now add them together to calculate for the net force. Now, going back to our previous discussions, since dito sa example natin, the forces are drawn horizontally. So, napakadali lang ang pag-calculate natin ng net force. We just need to add them literally. Na? So, you just need to consider, you just need to be careful of the directions, the sign that you are going to use on these values of F12 and F13. So, taking a look at the free body diagram, the direction of F12 is going to the left while F13 is going to the right. So, that means F12 is negative and F13 is positive. So, just use the sign and substitute the values. So, we can use this formula. The net force that the charge 1 is experiencing is equal to the sum of the individual forces of the charges. Okay, so F12 is negative 2.7 Newton. So negative means that the direction is to the left. Plus 8.4 Newton. So it is positive because the direction of this force is going to the right. Okay? And then apply mathematical operations, you will get the value of 5.7. So that is the net force that charge 1 is experiencing because of the presence of these two other charges. Alright, so that's it for our first example. Now, I have here another problem for you to solve. So, I want you to try this also on your notebooks. And we are going to find out the answer on our next face-to-face meeting. So, I'll be calling some students who can share their solution. So, please try this out. Eto, 3 charges on a line din to, na? So, try to illustrate them first and you are going to look for the resultant force on Q1, resultant force on Q2, and resultant force on Q3. So, you are going to see kung pare-pareho ba ang forces na na-experience ng mga charges or hindi. So, dito sa example natin, no? So, please try this out. Ayan. Now, let's try another example. Now, this time, it is much, not really complicated, but a much longer problem. So, here we are going to deal with the 3 charges on a plane. So, here in this figure, it shows 3-point charges that lie in the X and Y plane. So what we are going to find out is we are going to look for the electrostatic force, the magnitude and direction of the electrostatic force on Q1. So sa Q1 pa rin tayo nakafocus. But this time, hindi na siya line, no? Yung Q2 nasa taas na siya. So, nasa isang plane na siya. Meron na tayong X and Y components. So, the first step that we should do is to identify the known variables. So, isa-isahin natin siya. So, we have Q1, which is 4 microcoulomb, positive. Q2 is negative 6 microcoulomb. Q3, this one is negative 5 microcoulomb. How about the distance? So we have the distance between Q1 and Q2, which is 0.15 meters. The distance between Q1 and Q3 is 0.10 meters. And we have this angle formed because of the presence of Q2 and Q3. So the angle is 73 degrees. So we will be needing all of these variables to solve for the net electrostatic force on Q1. Now the next step that we have to do is the free body diagram. So we are going now to determine the direction of the forces by analyzing the charges. So, we have to look at the signs na meron itong tatlong charges. So, again, let's try to separate the different forces. Let's analyze them and treat them separately. So, let's begin with the force on 1 and 2. So, here is a simple illustration. Q1 is positive, Q2 is negative. So, the vector or the force that we are expecting is that the charge 1 is being attracted to charge 2. So, we can draw it just like this. So, that is our free body diagram for F12. Now, how about F13? So, as you can see here in the illustration, F1 is positive, Q1 is positive, Q3 is negative. So, we are expecting that Q1 is going to be attracted also to Q3. So, let's treat them individually first. So, meron tayong dalawang free body diagram for F12 and F13. Now, we are now going to calculate for the magnitude of the individual forces on Q1. So, again, F12 and F13 with the Coulomb's law. So, let's begin with F12. So, balikan natin yung illustration. This is our illustration. And this is the F12 that we are looking for. The force on Q1 by charge 2. So, applying Coulomb's law. So, we go back to the formula. Substitute the given values for Q1 and Q2. So, 4 microcoulomb, 6 microcoulomb, and the distance between the two is 0.15 meters. So, ayan, just substitute the values. Multiply the charges, we get 2.4 times 10, negative 11 coulombs squared. Square of the separation distance, 0.15 meters squared, is equal to 0.0225 meters squared. Divide the two, you will get, divide this, 1.06667 times 10 raised to negative 10 coulomb squared per meter squared. So again, please do not round the values here first. And then multiply it with the K, the proportionality constant. So when you multiply this, you will now cancel the value, the units for coulomb and meters. So the force acting on Q1 by Q2 is 9.6 newtons. Now, how about the force on Q1 by Q3? So, this is our free body diagram. So, eto, horizontal lang siya na. So, apply Coulomb's law, use the Coulomb's law. So, this time, F13, so we use the charge 3 and the distance between charge 1 and 3. That is 0.10 meters. So, substitute the given values and apply mathematical operations. So, the charges first, we get 2.1 times 10 raised to negative 11 coulomb squared. The square of the separation distance is 0.01 meters squared. Then divide this. Dividing the two, you will get 2 times 10 raised to negative 9 coulomb squared per meter squared. And then multiply, same just the same process. So, the force acting on Q1 by Q3 is equal to 18 newtons. So, obviously, mas malaki ang force on Q1 because of Q3. So, that is because of the distance. So, mas malapit yung Q3 compared to Q2. Now that we have those two individual forces, the next step is for you to find the X and Y components of each force. So, if you are going to look back to our previous discussion on the first part sa introduction ko, I have said that vectors have their individual, they have their components, the X and Y components. So, each vector has its own components, the X and Y. So I illustrated first the free body diagrams for each force. Ayan. Now, of course, itong F12, it has its X and Y components. Itong F13, this is also a vector. It has its components also. Now, I mentioned that when two vectors, if you are going to combine this now, here in this illustration, when two vectors interact with one another, it leads to a resultant vector. So, if you're going to analyze this illustration, si Q1 attracted kay Q2, si Q1 is also attracted to Q3. So, possibly, mapasain si Q1. Ano na ang direction kang force that is, resultant force that is acting on Q1? So, if you are going to look and analyze the signs, you are going to expect that the resultant force is somewhere here in the middle, because it is Q1 is both attracted to both charges. So we can actually assume. So let's assume na ito ang magiging resultant force. Okay? So now, we need to get the value of this. So, as I have said last time, to get the value of this, you need to get first the sum of the individual forces or individual components of each of the force that is acting on Q1. So, kailangan mo munang kunin yung X component and Y component ng F12. The same goes with this. You are going also to get the X component and the Y component of F13. So, dito sa F12 muna tayo. In F12, so this is the X component. Sorry, it's very small. No? So, you just draw the components here. This is the X component of F12. This is the Y component of F12. An F13 naman, it only has its X component since it is lying on the X-axis. So, this is the F13X and there is no Y component. Okay? So, kasi sa X-axis nga lang siya naglalay yung Q1 or the force on Q1 by Q3. Okay? So, binalikan ko po yung first part or the ideas that I have mentioned a while ago. So, we need to add the individual forces on that charge by getting the sum of the components of those forces. So, isa-isahin na natin siya. So, let's find the X and Y components of each force. So, let's begin with F12. So, ito yung maliit na illustration ko kanina. It is much now larger. So, this is F12, which is equivalent to 9.6 as we have calculated it using Coulomb's law a while ago. This is the angles, 73 degrees. This is the X component and the Y component of force 1, 2. Okay? So, again, to get the components, we are going to use trigonometric functions. So, to get the X component of F12, ito, we can use the cosine function. So, cosine is equal to the cosine theta is equal to the adjacent over the hypotenuse. Okay, so the adjacent here of adjacent to the angle of 73 degrees is the F12 or the X component. And the hypotenuse is the force 1, 2, which is 9.6. Ayan. So, just substitute the values. cosine 73 degrees is equal to x component of F12 over the force on charge 1 by charge 2. Now just rewrite this formula to get the value of the x component of F12. So we have cosine 73 degrees is times 9.6. Ayan, so 9.6 Newton times cosine 73 degrees is equal to 2.8 Newton. So that is the value for our x component. Now, how about the y component? Now, to get the value of this y component, we can use the sine function. So, again, sine theta is equal to the opposite over the hypotenuse. So, the opposite of this angle is the y component. So, F12y over the hypotenuse, which is F12. Substitute the values. Sine 73 degrees is equal to F12 or the y component of F12 over the hypotenuse 9.6 Newton. Rewrite the formula. We can now find the value of the y component of these F12 force. So, sine 73 times 9.6 Newton is equal to 9.2 newtons. So, we have now the x and y components of the force acted on charge 1 by charge 2. Now, how about the force or the components of the force on charge 1 by charge 3? So, we have the illustration here or the free body diagram. So, ito yung F13 natin. And the x component is just the same, actually the same with the force here because it just lies, again, it is just lying on the x component. So, again, use the cosine function. So, what is now our angle here? Is there an angle here? Wala. So, our angle is 0. So, cosine 0 is equal to the adjacent, which is F13x over the 18 newtons. So, apply or rewrite the formula. We can write F13x times cosine theta, cosine 0 times 18 newton. So, take note, cosine 0 is 1, I believe. So, try it on your calculators. Cosine 0. Ayan. So, cosine 0 is 1. 1 times 18 newton. So, the value of the x component on force 1,3 is 18 newton. Now, how about the y component? There is no y component here. So, we can just write 0 newton. Now that we have the components of each force, we can now add the magnitudes of the total force that is acting on both directions. So, add this, the x component, the resultant, the x component of the resultant force is 2.8 Newton plus 18 Newtons, it is 20.8. But sa libro, no, yung sa physics book by Catnell and Johnson, it is just, it was rounded off. So, it is now 21 Newton. So, sa atin, no, when we solve problems, wag nating i-round agad. Sa libro ko kasi ito kinuhang example. Now, here, the sum of the y component, 9.2 newtons plus 0 is just 9.2 newton. So, we have now these two components of the resultant vector. So, since we already have the components, we can now get the value of this resultant vector. So, to get the value or the magnitude of the resultant force, we are now going to use the Pythagorean theorem. So, we can draw it out now. So, just a representation. Ito, let's say, ito na yung net force or the resultant force. Ito yung sum of the x component, the sum of the y component, and what is now the angle? Now, because we have a new angle now. So, saan na ba siya? Gaano ba kalaki yung angle? So, those are the things that we are going to look or find out. So, let's begin with the magnitude using the Pythagorean theorem. So, using Pythagorean, so we can write the resultant force squared is equal to the x component of the force squared plus the y component of the resultant force squared. So, rewrite it. To get the resultant force, we will have the square root of fx squared plus fy squared. Substitute the values. Fx is equal to 21 Newton, while the y component is 9.2 Newton. So, get the squares of these two values. Ayan. So, eto na siya. Then, add the 2 and get the square root. You will get 22.93 Newton. So, that is the value or the magnitude of the resultant force that is acting on charge 1. Now, what about the direction or the angle? So, I use the tangent function. So, when we use tangent, it is TOA, no? So, opposite over the adjacent. So, tangent theta is equal to the opposite. So, the opposite of this angle is the y component, and the adjacent is the x component. So, Fy over Fx. So, since we are going to look for the angle only, we can rewrite this formula and get the inverse. So, the inverse of tangent, Fy over Fx. Substitute the values. Ayan. So, that is our angle. So, it is 23.66 degrees. So, kung sobra man, sa tingin nyo, sobra yung pagkaka-draw nyo ng angle, you can adjust the free body diagram that you have drawn following this angle. Kasi etong nauna nating illustration is more of nag-assume pa lang tayo na. So, since we already have the values, you can already adjust the length of the magnitude and its angle. So, eto yung result sa libro, no? So, tig-round off na siya. 23 newtons and 24 degrees. And this is now the final illustration. Ayan. So, that is how we solve 3 charges on a plane. So, it is simple. However, napakahaba ng process. Na medyo mahaba yung process of getting the forces. So, hopefully, you were able to follow this video lesson, and I recommend that you try this again. Try solving this again by while following the video. No, so, ayan. For the last slide that I have here, I want you to try again this problem. So, ito ang second problem that you have to solve on your notebooks. This is about 3 charges on a plane also. So, they have angles. So, try to look for the magnitude and direction of the resultant force on charge 3. So, this time, charge 3 ang focus natin. Dito tayo magfo-focus. So, please try to solve this on your notebooks, and we'll be checking this again during our face-to-face meeting. So, that will be all for this discussion. Bye!